This time we will explain about method of heat load calculation. We use the Japanese book that M&A design standard in Japan. We call the Brown Book. We would like to introduce what is the heat load calculation. It's to calculate how much heat load is generated and how much air conditioner should be selected. There is two types of calculation. First is steady heat load calculation. It's to be calculated peak load and use for AC capacity selection. Second is transient heat load calculation. It's to be calculate time varying heat load and use for simulation of thermal storage tanks and operating methods. This time, we will introduce steady heat load calculation based on the Brown Book. Let's understand what kind of heat load to be calculate first. There are two major calculations for summer and winter. For summer, we will calculate these load to be calculated. But for winter, several load is not necessary to calculate if compare with for summer. It's because these load to be safer side. It's mean making heat only. So, these load can be ignored for calculation in winter. Based on this background, we will explain the method only for summer in this movie. Before goes to detail, we want to explain the general rule for calculation. 1. Calculate the heat load for each room or space with different uses and conditions. 2. Dimensions to be picked up from drawing for heat load calculation. For external wall. Wall should be measure center of wall to center of wall. Height is slab to slab, not ceiling height. For interior wall. Wall should be measure center of wall to center of wall. Height is ceiling height. Next, rule of significant digits. We will define the following. Then, we will proceed with detailed method explanation for each load. We will start to explain about heat load from structure. To be calculate separate external and indoor partition. First, we will explain about a roof and external wall. It can be calculate from this formula. Calculate the heat load by multiplying the area, heat transfer coefficient, and temperature difference. Area to be picked up from drawing. Heat transfer coefficient to be calculate from this formula. It's meaning that how much heat can pass through each wall or roof. Therefore, it is necessary to calculate all the type of external walls and roofs with different specification for the calculation. To calculate heat transfer coefficient, it's necessary to prepare thermal conductivity. It depends on the materials. Table 2 to 4 shows the summary of thermal conductivity for typical materials. If you use special material or make exact calculation, it's better to refer the manufacturer specification. Next, effective temperature difference ETD. The reason why we do not simply use the external and internal temperatures for calculation. Because to calculate more accurate calculations with consideration the heat storage characteristics of the walls and roofs. Here, just explain how use these tables. 1. Select similar type of wall or roof. 2. Select thickness for each. For example, insulation L equals 25 mm and concrete D equals 150 mm. 3. Then, we will get type 3. This table 2 to 15b is the summary of ETD for each city. 4. Refer to table 2 to 15b for type 3. This table is made under the condition that the internal temperature is 26 degree. So if the internal temperature is not 26 degree, please make corrections according to the special note. Then, we can select ETD and ready to calculate for structure load. Next, method for indoor partition. We will calculate by this formula. We think you aware that, it's basically calculate the heat load by multiplying the area, heat transfer coefficient, and temperature difference. In case of indoor partition, we will not use ETD. We just use temperature difference both side of indoor partition like a indoor and outdoor. And more, sometime room to be faced non-AC room. In that case, we will use table 2 to 5 and calculate heat load from such kind of case. Here, we introduce outdoor design condition. This is Japan case. Table 2 to 11 is preparing necessary outdoor design condition for each city. Especially, we will calculate 4 kind of time in summer. We will calculate each time to verify the heat load together with radiation. Here, we introduce indoor design condition. Next, we will explain about heat load from glass. We have 2 kind of heat load from glass. QG1 is heat transfer load from glass. QG2 is radiation from glass. Total heat load from glass is heat transfer load plus radiation. Then, how calculate QG1 heat transfer load from glass? It also can be calculated by multiplying the area, heat transfer coefficient, and temperature difference. Each parameter can refer each tables. How calculate QG2 is radiation from glass? First, better to refer item 1 no shade. Standard radiation and shielding coefficient are multiplied to obtain the load per unit area. In case of with shade, formula is little complicated for calculating shadow locations, but it just reduces the heat load due to the shadow. We can refer to standard radiation from table 2 to 17. It also mentions standard radiation each 4 kind of time same as ETD. We can refer to shielding coefficient from table 2 to 16. We will explain about heat load from lighting fixtures. This formula is simple. It's just multiply the area and unit load. You can see table 2 to 7 for unit loads. We will explain about heat load from human. It can be calculated by multiplying number of occupancy and unit load. The heat generation from the human body is latent heat which using for dehumidification load and sensible heat which using for cooling. Standard values are listed in table 2 to 8. If the room temperature is high, you will sweat. So you can see that the latent heat value increases in 28 degree compare with 26 degree. We will explain about heat load from other heat source. Other heat source is like a heat generation from production machine, office equipment and so on. Here, we put sample formula for office design. We will explain about heat load from air leakage from outdoor. It's depend on the air balance design. If designed room to be a positive pressure, no need to consider air leakage from outdoor. If need to design negative pressure planning, better to consider heat load due to the air leakage from outdoor by the following. We will explain about heat load from outdoor air. This is one of the major factor of heat load calculation. Here, we introduce the formula to calculate from the volume of outdoor air. Ventilation calculation to decide the volume of outdoor air is one important calculation for HVAC. Let's explain the details of the method in other movies. Thank you for watching. In this channel, we will provide useful information for M&A design practice. See you again in next movie.